Trying to predict the stock market, it's like the holy grail of finance, right? People have been trying to crack that code for centuries. But what if modern AI could actually do it? Well, today we're going deep, and I mean deep, into the blueprint of a model that's trying to do just that. So that's the big question on the table. Can a machine, an AI, genuinely learn to predict something as wild and chaotic as the S&P 500? And look, this isn't about some crystal ball or magic trick. It's about data. It's about seeing if an algorithm can find the hidden patterns in all that noise and make a truly powerful prediction about the future. And we're not just going to talk about it in theory. Oh no, we are going to break down the actual blueprint of a really advanced forecasting AI. We're going to look under the hood, step by step, to see exactly how it's built, how it learns, and most importantly, how well it actually works. So here's our game plan. First, we'll tackle the massive challenge of prediction itself. Then, we'll introduce the star of the show, this AI with a special memory. We'll talk about the data it eats, how we actually train it, and then, the moment of truth, we'll see the results. Finally, we'll zoom out and see what else this incredible tech can do. All right, let's kick things off with the problem itself. Financial markets feel impossibly complex, full of emotion and randomness. But when you really get down to it, it's a data problem. And guess what? That is exactly where AI thrives. Everything in the stock market is what we call time series data. Think about it. Every stock price, every trading volume, it's just a point in a long, continuous story. To have any hope of predicting what happens next, you first have to understand the story that the data has been telling you up to this point. Okay, so to understand a complex story like that, you can't just use any old AI. You need a specialist. So let me introduce you to the hero of our explainer today, the Long Short-Term Memory Network, or for short, LSTM. This is an AI with a very, very special skill set. Now, before we get to the LSTM, you gotta understand its parent, the recurrent neural network, or RNN. See, most AIs kind of look at data one piece at a time, in isolation. But an RNN is different. It has this internal loop, which lets it pass information from one step to the next. It builds context. It's like how you remember the beginning of a sentence by the time you reach the end. An LSTM is basically an RNN on steroids. Its real superpower is its much more sophisticated memory system. It is brilliant at remembering important patterns from way, way back in the data, but it also knows what to forget, all the irrelevant noise. And for something as messy as financial data, that ability is an absolute game changer. Our model uses this really clever setup called an encoder-decoder architecture. The best way to think about it is like a professional translator. First, the encoder reads all the past data, let's say a sentence in Spanish, and it condenses it down into its core meaning. Then it hands that core idea over to the decoder, which translates it into a new language, a 5-day forecast of the future. It's a really smart way to divide the work. Now, any AI, no matter how smart, is only as good as the data you feed it. And trying to predict future stock prices by only looking at past stock prices, that's kind of like trying to watch an action movie with the volume turned all the way down. Sure, you can see what's happening, but you're missing so much crucial context. And that brings us to two very different approaches. The simple way is univariate, just one variable, the closing price. But our model is what's called multivariate. It's looking at a whole bunch of different data points all at once to get a much richer, fuller picture of what the market is actually up to. So what's on the menu for our AI? Well, yeah, we've got the closing price, but we're also feeding it trading volume, daily returns, and even classic technical indicators that human traders have used for decades, like RSI and MACD. Each of these adds another layer to the story, giving the AI the same kind of 360-degree view that a human expert would want. And does this richer diet actually work? Oh yeah. The source material shows that using all this extra data boosts the model's performance by a whopping 30 to 60%. So this isn't just a small tweak. The takeaway is clear. More context leads to dramatically better predictions, period. Okay, so we've got our super smart AI and we have our rich data set. Now for the fun part. It's time to actually train this thing. This is where we show it thousands and thousands of historical examples so it can learn the patterns of the past to predict the future. We do this with a technique called a sliding window. Here's how it works. The model looks at a window of 60 days of market data, all of it, and its job is to predict what the next 5 days will look like. Then we slide that window forward by just 1 day and do it all over again, and again, thousands of times. This repetition is what teaches the AI that deep connection between a 60-day history and a 5-day future. Now, training these kinds of deep learning models can get a little wild. Sometimes the internal adjustments the AI makes can spiral out of control and just explode, totally derailing the learning process. To stop that from happening, we use a trick called gradient clipping. It's basically like putting guardrails on the highway. It just keeps the learning process smooth, stable, and on the right track. So, we've built the model, we've fed it a ton of great data, we've trained it carefully. Which brings us to the big question, the one we've all been waiting for. Did it actually work? Let's look at the results. Okay, first up, we have a metric called maybe. All you need to know is that it tells us on average how wrong the prediction was in percentage terms. And our model scored 1.2%. Let that sink in. Its 5-day forecast for the S&P 500 was typically off by just over 1%. That's just incredible. Our second metric, RMSE, puts that error into real-world dollars and cents. The model's typical error was about $12.45. Now, when you're talking about an index that's worth thousands of dollars, an error that small is seriously impressive. It gives you a real feel for just how accurate this thing is. But how good is that really? Well, let's put it into context. The old-school, traditional forecasting models, like one called ARIMA, they usually have an error rate of around 2 to 3%. Our LSTM model, at 1.2%, literally cuts that error in half. In the world of finance, an improvement like that isn't just a step forward, it's a giant leap. So clearly this is a powerful tool for finance. But let's be real, the potential here goes way, way beyond just Wall Street. The same exact blueprint can be applied to solve all sorts of different problems. I mean, think about it. A telecom company could use this to predict network traffic and prevent outages before they happen. A business could use it to forecast which customers are likely to cancel their subscriptions. A software company could predict product usage to manage their server costs. Basically, if your business has data that unfolds over time, this kind of AI can probably help you understand it better. And that's the real key takeaway here. This AI blueprint is incredibly versatile. You can just swap out the S&P 500 data and plug in your own company's data. Sales figures, user engagement, whatever. This isn't just some cool science experiment. It's a practical, production-ready tool that businesses can use right now. So we've seen how a sophisticated AI can learn to find order in one of the most chaotic systems on Earth. When you think about these models getting even more powerful and being